better for you or comfortable for you?
I think oh, okay. Can you hear me? Can you hear me?
Yeah. You are
Hello?
audible.
Okay. All right. Okay. I like you are saying. I think I want to start from the bottom, from the basics, going up.
From the basics, right? From the basics, yeah. That is
Yes.
better actually. Um, okay, give me some time.
Okay.
I have conducted a robotics summer camp on robotics for school going kids up to 10th class. So I gave them a basic idea about this one, numbering system and electronics, and then CPUs, machine languages, and Arduino, how to use Arduino and how to use VBoards. One software is there, Python, and like how to code using Python. So in
Okay.
this, I should teach you are aware of numbering system, but not electronics, and you are aware of CPUs and machine languages, right from assembly level language for microcontrollers. How do we use code, and in C language, what was the code used, and then C++, Python. You must be aware of all this, and Arduino. This one you need to know electronics and Arduino, and then jump into PLCs. So
Mm.
I don't want to make this session boring, but before that, I will like to give you the introduction of the industrial environment. So, are you aware of this PLC? Have you ever heard about PLC?
Yeah. I have mostly
Yeah,
I've seen
PLC.
it in, yeah, like companies like electricity utilities and mining.
That's good. That's good. PLC, you see, it's a simple controller actually. It's a controller that have a hardware inside that. I mean, PCB you can call it. That PCB has got inputs section and outputs section and controlling section. Controller will be there. So that is what is this. Uh, as you know, like inputs. Wait, wait. Inputs can be like digital switches, or else um, there must be fan in your room. Fan must be having a regulator of 0 to 100% that comes into analog. And to switch on the fan, there must be a switch. That switches are called digital um, when it comes to industrial environment. And then we have got a CPU, and outputs will be there. Outputs in the sense there are uh, something we need to turn it on, off. Like you have got a phone in your hand, and in the phone, if you have button, some button called as fan on, if you turn it on, then the output will goes to the relay. Relay is again a hardware component that is used to turn on any machine or component, in this case fan. So the digital output, like the output that is going from the hardware PCB to the component, is we call these as outputs. And these are the three major components that any PLC can have: input section, output section, and a, a processor. On processor that have various types of protocols that communicate to other machines, like Profibus, Modbus, or RS485, RS45, or any other protocol, Ethernet or ECAT will be there. So these are the communication protocols Ethernet IP, Modbus. Modbus, are you out of these? How many are you aware of? Hmm?
If you are talking about a
This
PLCs, I think I just had an idea, but I didn't interact with them.
not related to PLC, but outside PLC, you must be using Ethernet IP
Oh,
address.
you mean, yeah, yeah, that one I'm aware of it.
Ethernet. So Ethernet we do use for this PLC, and this is Modbus and Profinet. These are bit older versions, but still being used. These are used for machines too. Machines in the sense few sensors have to communicate with the PLC through some communication interface. That interface are this Modbus, Profinet. There are very RJ45 will be there. So, and SCADA and VFD, we'll talk about that. So, yeah, for any PLC you have seen, there must be a program in that PLC. So, how do we write that program, and what sort of languages, what sort of coding environments are present in that are these one: ladder logic, structured text, functional block diagram, and sequential flowchart, industrialist. So out of these, the very now very commonly used is FBD and sequential function chart. So ladder logic was used in a like in early 2010s, 2010, and now ladder logic. Most of the programmers are not using this one. Now this functional block diagram and sequential functional chart are being used. So let me show you. Ladder logic will look something like this. Can you see the screen?
Yeah, I see it.
Ladder logic, and this is a functional block diagram, and this is a structured control language. So this is how it would be. And I've got one example for this one. This is a Word document. Ladder logic is will look something like this. This was used basically if you have a small limited number of inputs and limited number of outputs. In the sense, if you have a very small machine that have five inputs and five outputs and very less controlling environment, then this ladder logic will be used. Like you to turn on any motor and turn off the motor when some action is accomplished, and for such action, like you have a tank in your house, and motor, and whenever the tank level is low, turn on the motor. Tank level is high, turn off the motor. And for in such conditions, we use this ladder logic. You don't need to use heavy models for this one, like structured language and all. And this is a basic example. If the brackets are like this is called input, and this is output. These are the terminologies mentioned is present here, and this is normally open, and this switch is called normally closed. Only particular this one, open bracket, close bracket, and in between there is a backslash, that is called as normally closed. Don't worry, normally closed and normally open, these are the terminologies used for switches, um, which I can explain you on a later stage, like after knowing about electronics. And here the I start push button. Whenever you push the button, since it is normally closed in the sense current will keep flowing through this one, and this is overload trip safety feature. And if this feature is uh, enabled on, then the motor will run. So this is a push button, and if you remove the push button, there won't be any current flowing there. So this status is taken here, motor run status. So if you remove the push button switch, then the current flow through this one, and so how this motor will remain in on condition even if this push button is removed. I mean, um, uh, are you aware of push button?
Yeah, I'm aware of push button.
Yeah, push button until you press the push. I'm turning on my video. So until you turn on the push, that current will keep flowing through that switch. If you remove that, the contact will be removed. So current will not flow through that. Toggle switches are different. If you press the switch, it's on. It remains on. If you remove the switch, and again if you press the switch, it goes off. So there are different types of switches. This push button is being used here. Yeah, and then did you understand this one, this logic?
I was trying to make sense out of the diagram.
Fine.
So, like I was looking at the rows, like what do they mean? There's that first row where they say where there's I start PB, and then the
Yeah,
last
yeah,
item on the row is Q motor run,
yeah,
and then there's this on the middle one, the one that's
yeah.
just
This
on
Q
you.
motor run.
Yeah,
Yeah,
I'm trying to collect the whole thing, or is it a secret? I don't understand.
fine. No issue. Since like it takes time. It takes time. Don't worry. See, this is a simple output, a simple program, ladder logic program. I'll explain you. These straight lines are there. These straight lines are there. In between this, there will be a logic. This is a straight line. Or in this straight line, we can place n number of inputs, n number of outputs. Output will be in the end, n number of inputs will be placed. If all these satisfies, then whatever the output present here will be on. Understood? If all
Yeah,
this push button is on, if stop push button is in off condition, in the sense it is normally closed, and overload trip it is also normally closed, even if it is allowing the current, then this will be on. If any one of these fail, then the motor will goes off. Now let us understand what is this. I start push button. This is a push button that is used to turn on the motor. And there is some other button, push button, to stop the motor. So if you press the stop button, a continuous electrical pulse will be interrupted. So this motor will turn off. This is overload trip. Whenever the motor gets overload and some indication is there from the electrical circuit about the tripping, then this will remain off. So don't worry, there are many elements you are listening now, like push button, stop push button, overload trip button. Where are these connected? Where will these be in the panel and all? So these are the electrical components are present in the control panel, from where the signals will keep coming to the SCADA. So the same program, if we have to write in structured text, it is the same program. Now, can you see? So see, I start push button bool, normally open start button. Here there is a code. We have defined all the inputs and outputs, and the program is here. You this
Mm.
you
What is the programming language used here?
This is a structured text. It is
Okay.
C language only, but similar to C language. Every controller have got its own software to place the logic, ladder logic, or whatever the this structure test. So in that structure test, it will allow this coding. It is similar to C. You can see,
Okay.
yeah, but
Mm.
not C language. It is dedicated for that particular hardware. Allen Bradley, there are few models of Allen Bradley or Siemens, older versions of a PLC, where only this coding language is allowed. But nowadays, this is not being under usage. Even this ladder logic is under usage, but for a limited number of inputs and outputs for small machines. This is being used. And structure test is not in use, but you can be able to understand this one since you are into programming background. It is a simple
Yeah, I
like
can see. No, I think I can have it. I can have a guess what's happening. Like I can see this boolean. That's true.
yeah.
Mm.
And now it is not under usage. And this is functional block diagram. You can this is simply we can understand latching block. Here there are few terminologies: and gate, or gate, nor gate, not gate. Are you aware of gates? Have you heard of about gates anytime?
I'm not sure. I'm not sure. You mean in relation to what?
In
Like
relation to
electric
electronics,
circuits?
electronics,
Yeah.
and
Is
yeah,
it is it more like a power generator? You know, the backup generator.
no.
Okay.
So this is OR gate, and OR gate in the sense this is some logic. If any one of the inputs is on, then output will be on. AND gate, if both the inputs are on, this output will be on. And NOT gate, what if it is high, it will be low. If it is low, it will be high. These are gates that are used in programming language. Even for ladder logic also this will be used. These are present in engineering environment, engineering college. They will explain about this and gates or gates, and even in school time also in 10th class around, you might have heard about this one. Like this is a programming. These are logics that any programmer should need to know. Programmer here is PLC programmer, and this is SFC. Uh, Sequential flowchart, we can say. This is also similar to functional block diagram. Like block diagrams will be there: step one, step two, and step three. In step one, if action is it is the motor is in idle condition. It is also dedicated. These are like if it is a Siemens will have its own programming software, and in that software, the terminologies again will vary from software to software. I mean, company to company. This is structural flowchart. Now widely under usage. This one, since it is in the Word document, you are able to see in this format. Usually, it will be in blocks. And then this is instruction list. This is a much older versions software. And previously, we used to use this one um, for programming. This was used in around 2005 period. So don't worry, these are various programming languages used in developing the software, developing the logic with the help of PLC. That is what these are: the ladder logic, structure test, functional block diagram, sequential function chart, and instruction list. And SCADA. Have you seen SCADA anytime?
No, I haven't seen it.
Fine, no issue. Uh, do you have switchboard in your house?
Yeah, do you have what?
Do you have a switchboard? A switchboard in the sense the switches are present. Turn on the light, turn on the fan, or turn on AC. Do you have that switchboard? You must be having.
You mean the where the electricity is controlled, where like
Yes, yes,
connecting the plugs and the lights?
yes, 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 yes,
Oh,
yes.
yeah. Mm.
You have switches all there, and if you turn it on first switch, one light will be on the second switch, another light on the third switch, maybe the light that is present outside your house, and the fourth one could be fan. So you have seen that, right?
Yeah, I've seen it.
So usually to turn on the light, basically what you should need to know is connect the wires. What you should do is connect the wires of that light physically. Every time you cannot do that. So to make it simple, you have connected that to a switch, and you are trying to turn it on off easily to avoid hazard, or to make it friendly, user friendly. So now you have got a switch, and you have got many lights and many switches. So all those switches you have accumulated and placed it in single location, and you're calling it as switch board, and you are operating the entire house switches, lights, or any fan or any other controls through that switchboard. Now that switchboard, if it is a if it is a screen, your phone screen. So all the switches are present on your phone screen, and you are able to turn it on off through your phone. Then this phone screen is called as SCADA. SCADA is supervisory control and data acquisition system. Like this screen have the all the controls to control your house, all the switches to control your lightings, fan of your house. Understand? Does it make any sense?
Yeah, it makes any sense. Like it's a screen where you can call the hardware, you control the hardware part.
Yeah, exactly, exactly, exactly. That is what is a SCADA. In the industrial environment, there are many screens. People are standing in front of screen, and they are able to control the motor which is far away from him. So whatever the screen that he is looking at is SCADA or HMI. HMI is human machine interface. So now how do we connect the industrial components to this screen? So industrial components are Now, the industrial components are connected through to PLC first, and from that PLC to SCADA screen. So SCADA screen also, we have to develop the SCADA screen in such a way that whatever the input that is fed to the PLC will be considered as particular components input in the SCADA also. So SCADA needs to develop separately, and PLC needs to develop separately. Make sense?
Yeah, yes, it makes sense.
Fine. So that is what is SCADA means, SCADA and HMI means. And we have a few more options in the SCADA or HMI that you can get to know which light is in on condition for what duration. So you can take the data, and on what day, how much time this switch was in on condition. And you can also see what was the intensity, luminous of that particular room, and how many lights were in on condition. If the luminous is already reached, you don't need to turn on an extra light in that room. So suppose you have placed a sensor, luminous sensor. It takes the data of the light in that particular room, and it gives to the PLC, and PLC further assess, and whatever the set point required for that particular room will be compared with that process value, and then it gives the signal to the extra light to turn on or off. So this entire activity will be captured in the SCADA in and logs the data. So you can look at your data even after a year. So that is what is SCADA does. In short, this is very over what do you call? This is in short I am explaining, but there are many other components that I need to explain in brief. Uh, but I'm skipping all those because I'm giving a overlay of that SCADA now. And this is a control level PLC and communication bus. As I said, there is a sensor in your room. That sensor is giving the data to PLC. So, and whatever the data that is reached to the PLC, that graphical representation uh, uh, purpose, it is given to SCADA, and SCADA is giving the graphical representation. Suppose if your tank is half filled, so the using a level sensor, the data will be fed to the PLC hardware first. From that hardware, again, it gives the data to the SCADA. SCADA will show the data in user-friendly manner. What user can read very easily. Like assume a tank with half-filled water. So PLC and communication bus. PLC collects the data from various sensors and controls, and also gives the same data to SCADA using communication bus, which are called Ethernet. We can use any sort of protocol, Ethernet or Profibus, Profinet. There are many protocols through which we can communicate. And these are field device level sensors. Sensors, there are few sensors. That there are many sensors available in the market. A few sensors detects the object near to it, and a few sensors, if any object is moved from it, it counts the data. It captures the number of times it has crossed through it, and for temperature sensors, it captures the temperature and again sensors. There are It's a huge concept. Many number of sensors are present and actuators and VFD. Actuators, suppose, uh, um, suppose you have a tank and you need to turn off the valve, but keep the motor in on condition so that the water can flow to another tank. So if you have two tanks and a single motor is in on condition, two tanks are filling, one tank is filled fast, and for that, so water is not required. So in that case, we need to place a valve to that to keep by keeping the motor in on condition. So in such cases, we use um, actuators. Actuators, they usually do on and off, or it also do 0 to 100% open the valves. And VFDs are like, you have a fan in your house and it has the capability of running at 100% speed, but due to a weather condition you don't want that to run in 100%, you want that in 50% only. So you control the fan speed through a regulator. Since it is a fan, you have a small regulator. Since it is a heavy compressor in your fridge, so we need to have a circuit, thyristor circuit, to control the compressor. So to control the compressor, we need a heavy machine, heavy hardware, nothing but VFD, variable frequency drives. You must be aware, like whatever the current that we receive have some frequency, 0 to 50 hertz, or in your case 60 hertz, 65 hertz, something. So if you control that frequency of the electricity, then the output will be reduced or increased accordingly. That will be done here through VFDs. Please, any any comments or in
Okay, what does it stand for? VFD.
VFD? Uh,
Yeah.
here we have that. See, you have got a simple motor. Um, let me recall an example for you. Yeah, you have got a conveyor. Are you aware of the any conveyor?
But I've heard they are used. Yeah, they're used in mines like conveyor belts.
Exactly, exactly. The conveyor will be connected. A conveyor is a belt, actually, belt, and it is on two ends. There must be levers, and for one lever, motor will be coupled to it. So whenever the motor rotates that lever, the all the whatever the connected belt will rotate. On that belt, people used to put stones or whatever, and if you wanted to control that speed of the conveyor, you need some regulating device. That regulating device is a variable frequency drive. So variable frequency drive have got inside that there are many components. Thyristor circuit we call technically. Thyristor is a component that turns on off for about 10,000 times in a second. So by using that precise components, we can control the electricity flowing to the motor, and thus the motor rotates accordingly. Example, motor rotates in 100% if it receives 230 volts or 115 volts or 100 volts. And I have got this VFD circuit, and VFD is giving to the motor 50 voltage, 50 volts. So then obviously the speed of the conveyor will come down since the motor is receiving less voltage. So the speed will reduce. To explain in brief about this VFD itself is a big concept. See, whatever you have asked, it is a engineering concepts. These are all engineering concepts, and profession it's a course that was taken for years, and we can cover it in short time, but in this short span I can only give the knowledge this much. uh, did you understand about this VFD,
Yeah, I
like
understood.
why
Like
it's
you are
used?
saying, yeah, like the way I understood you, you said they are used to control the output. It's either you increase the volume, uh, or reducing the volume to a level that you want, not necessarily volume, like the speed or something.
Yes, yes. Yes, exactly. So this is outline. Whatever I have explained you is outline. But inside that, there are many other components. Again, we have to program that VFD, and VFD can also receive inputs, and it also gives the output to the motor. Inputs in the sense like, as you said, volume. So all the stones are falling in a room at a particular volume per minute. So we need to control that volume per minute. So we can control this output. To measure the volume present in that room, we need a sensors, and from that sensors that sensors will be connected to PLC again, controller, and then from that controller it controls the VFD. It gives the control signal to VFD. That is what is 4 to 20 milliamps or 0 to 10 volts. So this, based on this signal, the output to the motor, input of the motor will be decided. So So these are without a VFD, and this is with VFD and without VFD. With VFD, like we can uh, save the electricity and save the energy. Without the VFD, energy loss will be there since it runs in a single constant speed. And even while starting also, it takes a huge current. VFD will have a soft start. And coming to sensors, we have like proximity sensors and presence detection. Uh, you must have heard about like if a person enters into the room, all of a sudden the lights will glow, and if he leaves the room, the lights will turn off. Are you aware of this?
Yeah, I'm aware of it.
Yes. What sort of sensor could be present in that room?
I think it's kind of I don't want to say vision sensor. I don't know, but it's
Okay,
kind of
motion sensor we can call it as. If
okay.
some motion is happening, then it triggers a signal. If no motion, no signal. And you can keep a delay of 5 seconds or 10 seconds or 1 minute. For 1 minute, if there is no motion in that particular room, it triggers a signal to the switch controller. And controller, either it turns the light on or off, or fan on or off. We can that depends on the controller. Like here, the sensor is motion sensor. And apart from this motion sensor, we have many other sensors also. Ultrasonic sensors are there. Like you must be having a car, and while parking, if there is any object near to your car, then it gives the sound. Are you aware?
Yes, I'm aware.
Yeah. So how is it giving the sound? So there must be some sensor backside, right? That sensor
Yeah,
is ultrasonic sensor. What, like, if any object, we can program that sensor, it continuously gives the signal to out and receives the signal. If any object is interrupting its signal, it turns back to receiver. So assume this is a transmitter and this is a receiver. So transmitter is transmitting the signal, and it is, if there is no obstruction, it goes to infinity and no signal turns back to the receiver. So if any object is placed here, this signal will reflect from this interrupts here, and it turns back to the receiver. So this, whatever the distance between this obstruction and the sensor, we can program that, and we can define that. If it is very nearby, if it is 10 centimeters, then it should give a longer beep. And if it is 30 centimeters, we can call it as a warning signal. And if it is beyond that, it can ignore. So this is ultrasonic sensor that is being used in cars. So whenever it reaches any obstacle, it gives a signal, and thus we will this smart cars will stop automatically.
yeah,
So
I understand.
yeah, these are two examples
So,
of sensors.
okay, I understand you. So how large the object should be for the transmitter
Yeah, for the transmitter.
to
Yeah,
detect it?
the sensor is very small. Yeah. um,
I mean the obstruction. How large should it be, like for the signals to be returned back?
yeah, understood. It is 10 centimeters, or even 5 centimeters also.
Okay.
Yeah, this is that sensor. Can you, for the image purpose only, I've opened this one. These are the sensors. Can you see this one?
Yes, I can see it.
Yeah, this is that sensor. One side it is a transmitter, other side it is receiver. It gives a ultrasonic wave, and ultrasonic wave, when it comes back to the receiver, it uh, triggers a signal. And there are precise sensors are also available. This is 129, and wherein this, even that depends on the quality. Like this transmission signal will be there. Like if 30 centimeters, it can be the maximum transmission length, or 50 centimeters or 100 centimeters. This can be used for water also. In water also, like if the tank is empty, we can program that whatever the signal that is coming from the sensor, if the tank is empty, that will be considered as a tank empty. We have to program that in such a way that it gives 0 to 100% signal. For 0%, this many centimeters, 0%. And if it is 10 centimeters between the sensor and the water, it can be considered as 100%. We can program that, and we can show it as a display using Arduino circuits or any programmer controller. So now, uh, am did I answer to your question?
Yeah, you answered my question, even though I wanted to know I was imagining the waves in physical form, that if they are transmitted, how large should be the object? How large should be the object for them to bounce on that object?
Yeah, I mean, how long between the sensor and this object? Do you
No,
want this?
not long. Like say maybe it's size of a coin. Like can the waves detect
Okay,
the coin?
okay. If it is fly or what?
Yeah,
What did you
okay, a
say?
fly.
Fly. Oh
Yeah,
no, it cannot
say
detect
it's
the
it's
fly.
a fly. Mhm.
Yeah, yeah. That depends. Even I have not tested, but we have tested for small box. For mouse, we have tested, and it has to be in front of this sensor. This transmitter, whatever this transmitter transmit the signal, it has to reflect from that object. Whatsoever, how much soever be the uh, uh, length or dimensions of the object, but it points out on a particular location only. It has to be straight. It has to be straight, and that is what we have to work practically for that particular sensor.
Okay. Because
So
I
that
wanted to I wanted to imagine if you are faced with many use cases. Maybe I don't know. You want to
yeah,
detect something.
yeah. Uh,
Mm,
in this case, whatever the signal that comes out, it goes like this. It keeps increasing its frequency amplitude like this, like this. Can you see the screen?
I
Can
can
you see
see.
me? Like
Yes,
here there is a sensor. Whatever the signal that comes out will be going like this one. Imagine it is transmitting a signal in this way, in this manner, like this. So if there is an obstacle here, it cannot detect. Um, this is an option object, and this is my sensor. So if the sensor is here, and if the object is here, it cannot detect. If the sensor is here and the object is here, it can detect. So the signal that is coming from here, it keeps increasing its amplitude as the way it is traveling. So, and whatever the if some object is obstructing the signal, it repels back, and the receiver will always be waiting for the signal. So, how large should object be is depending on the signal and distance. So, if the object is large enough, but uh, near to the just above the sensor, where the transmitted signal doesn't reach the object obstacle, then it cannot. So it has to be in the range of that. This only then the signal can be received by the receiver. Um, it depends on the amplitude of the signal that is being transmitted. And whatsoever the small object, if there is any fly here, from the fly also some small signal will be received by the receiver, and again we have to program the in such a way that whatever the like a tiny signal also to be considered. Like it depends on the program again, whatever the like how much signal do we need to consider to uh, give the output is. Did I reach to your question?
yeah, I think you explained it very well.
Fine. See, it's actually 12:52. We have planned this session until 12:40 only, and there are few other slides. We are unable to make it now. Uh, maybe on
Okay,
we need
can
to
you show me the practical part? I guess these are just notes. Do you have other practical parts where you can demonstrate?
other practical.
Yeah, these are notes, right? Do you have the practical, like being hands-on? What do you use if you are now demonstrating with a practical
Yeah,
example?
I have got Arduino circuit. I've got Arduino. Arduino. Are you aware of Arduino?
I've just heard about it. I'm not aware of it.
Yeah, I've got Arduino and this sensor and basic sensors I have, and this controlling Arduino software. we can go with that. That is basic electronics. And PLC, I don't have PLC now with me. Uh, and SCADA software, I don't have installed in my system now. We can install that, but it needs a license, and we can get 1 day license, and every day we need to uninstall and install that software, SCADA software. And SCADA for and programming PLC also we need a software. These are our licensed softwares. Freeware very hard to find. And yeah, I have very limited hard infra now with me. Uh, this Arduino circuits I have, and basic sensors. I have got the temperature sensors, ultrasonic sensor, and obstacle sensor, IR sensor. I have. What I can provide you is I can make you understand how the industrial environment will be like, and I can show you various sensors which are connected to various rooms or environment, and how is it being controlled using Arduino, and how can it be monitored in your screen or in your phone. This we can do, and that is what. Any other?
Okay.
Yeah.
No. Okay. The other thing that I was expecting is for you to show me your online portal, or is it your online learning platform?
Online learning platform, fine.
I thought you were going to take me through.
Mm, Uh,
Oh, wow, oh,
See, I have got one software. This is my software. This is an app that I have built. I can share you this app. This app will have daily classes. In that, like daily no, interactive class will be there. And after the class, whatever the lesson that have been taught will be sent to the student usually. And are you asking this one only or any other?
okay, no, I thought you have like a live, maybe a live LMS, learning management system, where you've got
That is
everything.
what this is, learning management system only, but this is a mobile Android app that I've designed for my students. But this is for students only. In this one, there is no PLC, there is no SCADA. In this one, there are it is for students, so there are few games on basic electronics. Circuits are there. Connect the how to connect the circuits part and all, and then Sudoku is there, and one more game is there. So this is not for someone who are already working professional. Um, it is not. It is a LMS only, but for students. Usually, we don't get such requirement on industrial environment teaching. So that is the reason we don't have this LMS. We have to
Oh,
we have to take every day. We need to like every day it has to be a new session, and even after a month, again it changes, versions changes, and there are many things that change, that keeps changing. But for basic electronics, this app will work, and that's all. And this is for Arduino also. And for Arduino also, I software have like you can and you can control your house with your phone by using um, Arduino circuits.
okay.
But when it comes to industrial environment, we usually don't keep PLC at home or in my institute. Even SCADA also we don't usually keep, because these are all theoretical languages, theoretical studies. But uh, if it is physical session and there are many people who are interested on this one, then we can buy one PLC and we can connect the elements to the PLC and we can show that. Since it is an online, um, we can hardly demonstrate on this one. Like we don't have simple question. We don't have. Yeah,
Okay, no, okay. I was not asking for that. I thought you've got like like I said, an LMS where you put your notes and everything, and then what I do is just come and open like a self-service, like not receiving, receiving with an email. Sometimes you have to download the.
yeah. This is what is every day we have
Mm,
got. I'll be sharing this PPT. This is a day one PPT, and this is day one
o-
notes. This will
okay.
be present in the LMS. This is I push the data to my app, so my students will open this one on that particular day. Whatever the lessons that I've taught, they will go through this one, and I've also given them this document. In this document also, uh, what should be taught is there, and what was taught is there. And this is, since this is an introduction class, like this content is appearing, and for we have got this app, whatever you said, but not particular on your case. This is in generic to summer camp on robotics for school going kids, where they will learn about this basic electronics and all. I can develop a curriculum, no issue. This curriculum is built by me, is developed by me only. This whatever the curriculum that I have here, this is curriculum for this particular summer camp. If you have any particular list of items, I build a curriculum, and what shall be taught, what shall be included apart from the contents you asked, and what sort of examples that I have to place. And I can make an app, and I can give the app for you, and you can go through that every day. I'll push the data every day after every day's session. I can do that.
Okay, yeah, no, no problem.
So any other any other questions? Basically, I'm an instrumentation engineer. I've completed my BTech in 2008, and I've worked in many engineering sectors. So finally, I'm working. I have my own business now. I've got a sanitary pad manufacturing unit in India, Andhra Pradesh, Anantapur, and I've got this company name is Runout Texel Private Limited. I'm the business lead for that. And apart from that, whatever the knowledge that I've gained from my industrial exposure is being taught to various professionals, and also I'm teaching school students on robotics and various sensors, how to be used and all. I'm That is what I'm doing now, and I've worked in many engineering sectors, defense, high pressure, high vacuum, and high temperature, and cement plant, steel plant, and pharmaceutical industry. In these areas, I've worked. Uh, this is about me in short. You can find my profile in LinkedIn. I'm Ram Mohan Reddy. Uh, you can find you if you want to know about my profile, Runout Texol Private Limited. If you can type
Hello,
this in LinkedIn, you can find my profile.
sir.
This is what about me.
Hello.
Yeah,
Yeah, sir. Demo session is completed, sir.
yeah. It is not completed, but we have to finish that now.
Okay. After demo, hello.
Yeah,
Yeah,
please.
after completion of the demo session, you have to tell to me, sir. I can speak with the student.
Yeah.
Okay, sir.
Uh, in Do you have any other questions to ask?
I know. I don't have another question. So I was interested in. I saw that you've listed a number of softwares that you are going to teach your students. So I thought I was going to see kind of an example, but I've heard you that you say for those softwares you have to
Hmm.
reinstall after expiry period.
Yes, yes, yes. That since we don't have that freeware available in the net, or else we have to crack a few versions. That is not appropriate to do that. Not official.
Yeah. So All right. For my part, I was more interested in seeing the practical softwares that have been used. So I thought you were going to list them to say you are going to learn this software and this and this and this. I've seen
Yeah,
something like Siemens. I don't know if I'm saying it correctly.
you're correct only. Siemens, uh, yeah, we have got Siemens. This is what Siemens schematic, and this is how the PLC look like. And this is motor, this is VFD, and these are Siemens modules, input output modules. Can you see the screen?
I can see the screen. Yes.
Yeah, but before you understand about basic electronics, you cannot jump into this. Jump into this. Yes, but even for programming also, you need to have a basic knowledge about um, basic electronics and a few terminologies like AND gate or gate, and uh, unless you have that knowledge, you cannot step into this programming part. Uh, that is what my personal opinion. Uh, which you may or may not consider.
Oh, okay. No, I didn't want to like go into deep details. I just wanted to like know what you have, the softwares, like what,
Yeah,
like giving me the whole picture of the course, like what really am I going to learn? Because now you're just showing me like a slides, showing me the
yeah, that
notes, but
yeah.
but
We can.
mm,
That is what. If you have any particular such requirement, I have developed a Siemens SCADA and logic, and I can explain Siemens, LM Bradley ABB, and uh, that's all. I can explain these two in real-time environment, but um, I need to see if the cracked versions are available in the internet. Download that and begin. And the SCADA also we can do. And we can develop the SCADA where what components can be uh, like incorporated into the SCADA and all. We need to see. Maybe we need to have another session on this. Um, for I was like, no, the exact requirement was not reached to me. So, or else I would have straight away downloaded, tried to download any software instead of this PPT.